All right, so we're looking at how to calculate the cost of redeemable debt. Okay, so a company has 5 million kwacha of 10% redeemable bonds in issue, which are currently trading at 105 kwacha per 100 kwacha nominal. So this debt is trading at a premium because you're paying 105 kwacha. The market price, this 105 kwacha, is above the par value or the nominal value of the debt. Okay. It is redeemable in 4 years' time. So as I said, colleagues, how you know whether debt is redeemable or irredeemable, if they mention whether it's redeemable in 4 years' time or it matures in 4 years. If you just say time is given in the question in terms of years, then you know you're dealing with redeemable debt. Okay. So here we have to calculate the cost of debt. Okay. So when you're dealing with redeemable debt, the first step, calculate the after-tax interest payments. Okay, the after-tax interest payment. If you remember, for irredeemable debt, remember this I1 minus T. This is basically what we're doing here. Okay, so the after-tax interest payment for the bond is the interest rate times the par value 1 minus T. Okay, so here our interest rate is 10%. Our tax rate, oh, I never put tax here. Corporate tax is 20%. So here 1 minus 0.2. Okay, so 10% of 100 kwacha is 10 kwacha. 1 minus 0.2 is 0.8. So 10 times 0.8, that is 8 kwacha. Okay, so that's the interest, after tax interest payment. Any questions? All right. After you find the after tax interest payment, this is step one, get the after tax interest payment. After that, now we're going to use the internal rate of return for calculating the debt. Okay. So you don't need to make this table, but it's advisable if you can make this table. All right. You have your years in the first column. Your second column, you have your narration. Third column, you have your cash flows. Fourth column, your discount factor at 10%. Remember, your discount rate, this is important. The discount rate is the interest rate, okay? The discount rate is the interest rate, okay? Yes. So you start year zero. You're going to put here market price of debt. It means the person is buying the debt at the securities exchange. Okay. This table is going to show us how this debt works. Okay. Year zero, which is the first day of year one, you purchase this debt at 105 kwacha. That's why I'm representing it as a negative number, because this is a cash outflow. Okay. You pay 105 kwacha. Okay. And you acquire this bond or this debt. Then from year one to year four, you'll be receiving interest payments. Okay. From year one to year four, you'll be receiving interest payments. This represents an annuity, because remember, an annuity is where you're getting paid the same amount of money over the same time interval. So in year one, you get 8 kwacha, year two, 8 kwacha, year three, 8 kwacha, year four, 8 kwacha. Okay. Then finally, in year four, you get paid the par value. Okay. This is when the debt matures. Okay, in year four, right? And in year four, apart from getting your final interest payment, you also get paid the par value. That's why I've put 100 kwacha here. Any questions before I go further? Year zero, first day of year one, you pay for the debt, cash outflow. Then year one to year four, you'll be getting interest payments. Okay, you'll be getting interest payments. You'll be getting interest payments. Year one, 8 kwacha, year two, 8 kwacha, year three, 8 kwacha, year four, 8 kwacha. Okay, you get all your interest payments. Then on the final year four, after you get your final interest payment, you get paid the par value. So what we're going to do now is we're going to find the present values of these monies. Okay. So this is here, this one, discount factor at 10%. This is where you go to your annuity table. Okay. So here I've got an annuity table here. Okay. Always look at the formula on top. This is, if you don't, you're not using the table, you use this formula here. Okay. So we're going to look for our discount rate, 10%. All right, 10%. Then we're going to look for year four. Okay. So year four is here on this side here. Okay. So our annuity factor, 3.170. So here, let me see in here. In year zero, the annuity factor is always 1. Okay. So in year one, in year zero, here on discount factor, you put 1. Okay. Then year 1 to 4, the annuity factor here, 3.17. Then finally in year four, okay, we go to our this. So for year four, the discount factor, this time you go to the present value table. Okay, you look at the formula on top. This is for the present value. It means it's present value here. You're going to come discount rate 10%. Then you look for year four. Year four is here. So our present value factor is 0.683. Okay, that's where I've put here 0.683 there. Okay. Is 0.683. So all these values, I got them from the tables. For the annuity, you go to the annuity table. Then in year four, since you're being paid the interest payment once, that's why we go to the present value table. Then after that, just like how, remember, present value is just the future value multiplied by the discount factor. So we'll be multiplying these values here. Negative 105 times 1, we get negative 105. 8 times 3.17, you get 25.36. 100 times 0.683, you get 68.3. Okay, you get your present values. Remember here, what's happening here is we're just getting present values, okay, colleagues? So do not be confused with this year and the narration part. No, here we're just getting present values. Okay. Any questions before I move further? Okay. Then we add our present values. Negative 105 plus 25.36 plus 68.3, you get negative 11.34. Negative 11.34. Yes. Now remember, with the internal rate of return, you're supposed to get two present values. One should be positive, one should be negative. Okay. So if your first present value is negative, remember this, colleagues. If your first present value is negative, it means you reduce the discount factor. Right? Then if your first present value is positive, it means you increase your discount factor. Okay, so it's up to you how you want to increase or decrease. Usually, if you're decreasing, just divide by 2, okay, so that you're not doing trial and error. Okay, so you can divide by 2. Or if you want, just pick any discount factor below 10%. Any discount factor below 10%. You can use 9%, 8%, any of them. Okay, you can use any discount factor below 10%. So here I just divided by 10 so that I use 5%. But you can use any discount factor. So once you've determined your new discount factor, you go back to the tables. Year 0, your discount factor will always be 1. Year 1 to 4, we go to our annuity table. 5% is here. In year 4, our discount factor is this one, 3.546. 3.546 here. So we put it there. And then for the final year, okay, you go to your present value table. The reason why I was using the annuity table is because interest payments are like an annuity. Okay, so year 4, present value table, you first look for 4% here, then you look for year 4 is here, so our value is 0.855. 0.855. Let's see the 4%. 0.855, yes. Then we do our multiplications again. Okay, it's just a repetition of what we did earlier on, right? So you say negative 1.05 multiplied by this 1 here, you get negative 1.05. That's happened there. Are you there, colleagues? Just hold on, the page reloads. Let's see, why has this page gone off? So we say Yes, here again. Okay, yeah. So negative, we say negative 105 cash flow times this star one. 1 times negative 105, we get negative 105. Then the next cash flow, we're going to say 8 times 3.56, 3.546. 8 times 3.546, we get 28.368. Then the next one, we're going to say 100 times 0.823, we get 82.3. Okay, then we get our present value. So you say negative 105 plus 28.36 plus 82.3, you're going to get 5.66. Okay, a positive present value. Any questions? 5.66. Any questions before we put in the formula for the internal rate of return? Okay. So now when it comes to putting in the formula for the internal rate of return, there are just four figures you need from this table. Just four figures. L% is the lower discount rate, which we used as 5%. H% is the higher discount rate, which is 10%. NPVL is the net present value with the lower discount rate. The lower discount rate. So the net present value with the lower discount rate was 5.66. Okay, the net present value with got with the 5% discount rate was 5.66. Then NPVH is the net present value with the higher discount rate, which was negative 11.34. Okay, colleagues, those are just the four things you need from the table. Okay, the lower discount rate, higher discount rate. The net present value with the lower discount rate, net present value with the higher discount rate. So here we just substitute in our formula. 5% plus net present value with the lower discount rate, 5.66, divided by NPVL, the net present value with the lower discount rate, 5.66, minus net present value with the higher discount rate, negative 11.34. Right, then open brackets, H%, the higher discount rate, 10%, minus 5%, the lower discount rate. and then you solve. So you're going to say 5% plus 5.66 divided by, so here in the brackets, we're going to say 5.66 plus 11.34, since the negatives make positive. So 5.66 plus 11.34, that is 17. Open brackets. 10 minus 5%, that is 5%. So we say 5% plus, and you do 5.66 divided by 17. You get 0.3329 multiplied by 5%. So 0.3329 multiplied by 5, we get 1.664. 5 plus 1.664, you get 6.664. And that is our cost of debt, after tax cost of debt, 6.664%. Any questions?